Today we are going to add to what we were working on yesterday. So we got tables, tables, and more tables to work on today. So we're going to do a couple of examples. This should look very similar to something you had yesterday. Now yesterday we were checking to see are they actually proportional. So we were multiplying our diagonals to make sure they were proportional. Well, today I'm telling you up front that everything is proportional and we have to figure out what is missing. So for example, if I wanted to put an X here, what would this X equal? What would have to go in this position in order to make this table work? Because it's already proportional, we just got to figure out what's missing. So if I want to look at just a little bit at the time, like we did yesterday, if I put 7 over 10 equals 3.5 over X. Now this should look very similar to what we did last week. We're going to still look at our diagonals. So we got 7x. I like to go wherever my variable is because I like for my variable to be on the left. And then we have 3.5 times 10. If you want to just double check, most of you can do it in your head, but if you can't, double check, we got 35. So if I have 7 times x, the opposite of multiplying is dividing. So I divide both sides by 7. 7 divided by 7 leaves me just plain x. So then 35 divided by 7 is going to give me 5. So I know that 5 would go in the table and it would keep everything proportional. Remember, we could think about it like yesterday we were thinking this is x and this is y. So just to think about yesterday, if I wanted to do my constant of proportionality, I would do y divided by x. So I would do 2 divided by 4, which would give me 0.5. 0.5, and then 0.5. So my constant of proportionality would be 0.5. But the value that was actually missing in this one was a 5. Okay, let's try another one real quickly. Oh, I can't pick up my paper. Okay, this one, similar table, and we're going to say that we want to figure out what is x. Well, if you want to cover it up again, you can. If you don't want to look at that part, we can cover that up, and we got 2 over x. Get a different color. 2 over x equals 120 over 180. So if I slide this over a little bit, again, most of you could probably do this in your head. I like to do my diagonal with my x. I got 120x equals 2 times 180, I believe that's 360. Yep. And then I'm going to divide both sides by 120. And then x equals, I believe that's 3, but if I just want to double check, and that is indeed 3. So what's going to go in this position is 3. So to keep this table consistent, we know that a 3 is what we had missing. Now, if you wanted to go back and do what we did yesterday for constant of proportionality, again, this is x and this is y. You would do 120 divided by 2. You could do that way to find your constant of proportionality. But we're going not going to focus on constant of proportionality anymore. We're going to just, to keep the video a little shorter, because yesterday was really long. Now, this time I got 2 numbers missing. So what in the world am I going to do with that? Well, if I look at this section, there's no way that I can solve because I've got 2 things missing. And if I got 2 things missing, I can't have 2 x's. That's not going to work. But if I focus on just this section, and let's solve this proportion. So if I do 15 over 20, and I set that up to 3 over something, so that's going to be my x. So I like to start with that 15x equals 60. So if it's 15 times x, opposite of multiplying is dividing. So then x is going to equal 4. So now in this position, I know this has to be 4. So now if I slide down, I've got more information. So now I can focus on, and if you don't want to look at all of those numbers, if you want to just, you could solve that proportion, or you could solve this proportion. Remember, if they're proportional, it doesn't matter which one we do. So if I want to do 20 over 25 equals 4 over x, I'm going to do 20x equals 100. So I divide both sides by 20, and x equals 5. So if I solved it that way, I got x equal for 5. Well, just for curiosity's sake, let's say I didn't want to do that one. I wanted to do this one. This is a little bit different problem. So I wanted to do 25 over 30 equals x over 6. I'm going to go with my variable first. So 30x equals, that's going to be 150. Divide both sides by 30, and x equals 5. Whoops, well, I didn't show you the problem. I'm sorry. X equals 5. So either way, you're going to get the same answer, but the reason why you're going to get the same answer is because it is proportional, okay? So it didn't matter which one you decided to do, okay? So now we've got one more, and remember yesterday we had some horizontal and some vertical, okay? So I'm going to just cover this up with my calculator so I don't have to look at as many numbers because I don't want to get confused and overwhelmed. So I'm going to put an X where that blank is under that 5. If I could get my paper to work for me. So if I put 5 over X and 15 over 21. So I've got 15X equals, and 21 times 5, I think, yep, 105. And then I'm going to divide by 15 because that's what's with my X. And I get 7. So that means that this number is 7. So if I keep looking in my table, I can't solve that because there's too many things missing. But I could look at that. Well, not too much junk up here. I could look at that part and see how to solve it. So if we do 15 over 21 and set that, just put the x for that. So we get 21x equals, and if I do 15 times 63, 945. And then I'm going to divide by 21. And I get 45. So if I put a 45 here, then I can slide over and solve that last section. So then I can slide over here and do 45 over 63 equals 135, and I'm just going to put an X in that position because I don't know right now what that is. So I get 45X equals, if I punch that in, 63 times 135, and I get a big number, 8,505, and I'm going to divide both sides by 45. And I get X is going to be 189. Because remember, 45 divided by 45 just leaves me with that X. So this is going to be 189. So to backtrack for just a second, if this is proportional, then I should be able to divide. Remember, it's Y divided by X. And let's see what our constant of proportionality would be. They should all be the same if I did everything correctly. So let's do 7 divided by 5. So I get 1.4. Let's do 21 divided by 15, and I get 1.4. So far, so good. 63 divided by 45. Remember, this is telling me my unit rate or my constant of proportionality. So I did 189 divided by 135. So 1.4. So that means I got everything correct. It is still proportional, and my constant of proportionality is 1.4, and I found all my missing numbers. So just to kind of give you a glimpse into the future of next week, if you think about X's and Y's, you're probably thinking about graphing. So after we finish these tables and master what's going on with these tables, then we're going to have to move into graphing these tables. So just to kind of give you a heads up of where this is going. I will see you tomorrow.